Okay, here's another one of those technologically enhanced items where you're going to drag the numbers into the box, but in this one we are going to try to use some delta math, but some Desmos, but the more that you know about this, the better off you will be. So one thing that you might want to know is this graph has a minimum of 2. So this graph would have a minimum value of 2, and it would have a maximum value. We don't know. It doesn't tell us the maximum value. So a minimum of 2 is important, and it tells us the period is 6. Well, the period is something I can actually use. You might remember that this b value, this number in front, should be equal to 2 pi over the period. So that means my b value, I'm pretty confident, is pi over 3. And if you can narrow anything down on these technologically enhanced items, it's going to help you a lot. The other thing is, it also gives you this information about what happens at this value. That's going to be useful as we go to Desmos, but I'm ready to go to Desmos and see what it can help me with. So we're going to try typing this in Desmos, and I'm just going to type it in as is, a sine of bx plus h. And it offers me sliders, and I say sure. And initially it's nowhere close. I'm looking for a minimum value of -2. It doesn't have that. It doesn't probably doesn't have the correct period or anything. So what we're going to do is I'm going to start by typing in what I think the period is, which is pi over 3. And I'm also going to look to see it should have a value of 2.55. Now one trick to help you with that, instead of having to click it over and over, since the y value of that point is supposed to be 5, I'm going to type in the equation y equals 5. Oops. And I'm basically, first of all, going to have to get that graph to hit a 5. So h isn't 1, but it might be 2. Nope, that doesn't get me up to 5. It could be 4. Okay, that gets me up to 5, and I'm looking for a value of 2.55. Well, that's not going to work. Keeping going, h could be 6. That also doesn't give me a value of 2.55. If I make it bigger, 8, that's clearly going to be too much. So messing with just h didn't work. Let's go back to h is 2, and let's start messing with a. So if h is 2 and a is 2, you notice it still doesn't work. But now that I've let a be 2, I'm going to have to try and mess with h again. So I'm going to make h be 4, and that's 2.5, I think. Yep, and the minimum value really is 2. So I think we have winner, winner, chicken dinner. I have a minimum of 2, 2.5, and then I believe the period is correct. If you want to check the period, you can just check the distance between minimum points. So the distance between there and there should be 6. So if you count it, if you zoomed in a little bit and counted, it would be 6 between 1.5 and 4.5. Or if you just subtract the distance or the difference between 4.5 and 1.5, it's 6. That's a tougher one, but by narrowing it down with the period, it becomes a little bit more manageable. If we have some time at the end of the video, I'll show you the way to do that without having to guess as much on Desmos, but if not, you'll live. Okay, on the next one, the vertices of this triangle, and it talks about rotating it. Okay, so if it's going to talk about shapes, it doesn't show me. I want to see what they are. So there's 0, 0, over 6, up 6. You notice I'm not getting super picky. And then over 9, up 3. Okay, and it says it's going to rotate this triangle around the line y equals x. Well, the line y equals x, you might know that that's the places where the x and y coordinate are equal. So that's places like 0, 0, 2, 2, 4, 4, 6, 6, 8, 8. It would be this line here. What it means to rotate about that line is it means it's going to spin it around that blue line. So basically I would be spinning it like this. So you can kind of get the idea of the shape you would have if you spin it like that would be some kind of a cone. So I have some kind of a cone, and to figure out things about the cone, what I need to know is it wants to know, let's see, volume. So volume of a cone is 1/3, because anything that comes to a point, you do put a 1/3 in for volume. And then the area of the base times the height. Volume is always area base times height, and if it's something that comes to a point like a cone or a pyramid, I put a 1/3 in there. So 1/3, and the base this time looks like a circle, so the area of a circle is pi r squared times h. So that's the volume of a cone. Now I'm going to have to figure out the radius and the height. So the radius of this cone would be this length here, and the height would be this length here. So to find out the height, I'm going to redraw some of these triangles because I kind of made a mess of that first one. I guess I'm going to redraw it over here because I got to be on my page. So that's 0, 0 to 6, 6. And that gives me 6, 6 like that. If this is the point 6, 6, to get there I went over 6 and up 6. And then I need to know this side is my height. So it looks like a good time for Pythagorean Theorem. 6 squared plus 6 squared equals 8 squared. Could put that in Desmos, but that's going to be 72 equals 8 squared. And h is basically going to be the square root of 72. So that's a good start there. Radius. I'm going to make me another little diagram. I'll do this one in blue for my radius. Radius goes from 6, 6 to 9, 9. So 9, 3. So if this was 6, 6 and this was 9, 3, I went over 3 and down 3. And I could use Pythagorean Theorem again. 3 squared plus 3 squared equals r squared. And this is it's a little bit of a pain, you not being able to count and having to use Pythagorean Theorem for both of these, but we're getting it done. 18 is r squared. And I could take the square root of that, but you notice r squared is actually what I need. So I'm not going to take the square root and then square it again. So here we go. My answer should be, by plugging into this equation here, I'm running out of room to write here, that's going to be 1/3 pi times 18 times square root of 72. And the unfortunate thing is they've simplified that so it doesn't look exactly like any of those. So I have to say, okay, this 72, what would it break down to? Well, I could take out a 2, that would leave me a 36. Take out a 2 again, that leaves me an 18. A 2 again leaves me with a 9. And finally I get a pair of 3s. Remember, I'm looking for things that pair up. So pairs of 2s, pairs of 3s. If it has a buddy, it gets to come out of the root. So I have a 2 and a 3 come out of the root, and then a 2 stays inside the root. Quite frankly, they all had a root 2, so I should have known it was going to be a 2 left inside. But anyway, when I simplify that now, I'm going to have 2 times 18 would be 36. So 36 pi root 6 when I simplify all that, because the 1/3 and the 3 cancel. And then 18 times 2 is that. That gives you all of that jazz. Now, the problem with this is that was a whole bunch of simplifying. If you could have gotten to the point that you had this substitution step here that I have in the green, you could have typed that in Desmos and then done matchy-matchy. But that one had a lot going on. Let's go ahead and look at the next one. On this one, it's talking about a parallelogram, and once again, if it talks about a shape it doesn't show me, I'm going to draw it. Be very careful as you label this parallelogram. N, M, P, T. You have to go in order. I have students sometimes that will try to do something like this. They'll be like M, N, P, T. You can't do that. You have to go around in a cycle in the order they give them to you. So N, M, P, T. Now it says angle M is 6x plus 10. Angle N is 5x plus 10.5. Now when you have angles around parallel lines, they're either equal or they add to 180. And in this case, they don't look equal. This one is bigger than 90 degrees. This one's smaller than 90 degrees. They can't possibly be equal, two different angles, so they must add to 180. So I have 6x plus 10 equals, plus 5x plus 10.5 should be equal to 180. So if I'm going to add those up, I could simplify and get some answers. Actually, at this point, if you wanted to, you could put it in Desmos. But I have 11 plus 20.5 equals 180. Subtract 20.5 from both sides. So that's 11 equals 159.5. And at this point, I finally am going to reach for Desmos. Get that last mass gone. 159.5 divided by 180. New divided by 11 is 14.5. So that tells me x is 14.5. Now, I feel really good and I'm about ready to go on with my life. But anytime you do a problem, especially a geometry problem, read and make sure what it's asking for. It's not asking for the value of x, it's asking for angle t. So I'm going to take the 14.5 and I'm going to have to find out angle t. Well, neither one of those is t, but notice I said around parallel lines either angles are equal or they add to 180. So t looks like it equals n. They both look like acute angles, and they are equal to each other. Opposite angles in a parallelogram are equal, so if I could just find n, I would know t as well. So I need to plug 14.5 in for n. So that's going to give me 5 times 14.5. Plus, I believe that was, 10.5? And that gives me an answer of 83, and that is your final answer of 83 degrees. So be sure you read carefully and don't stop short on these problems. Keep going until the end. The next one I'm going to look at is 24. It tells you these diagonals intersect. And it's a rectangle. Well, the truth is the diagonals of a rectangle, when they intersect, they bisect each other or they cut each other in half. So IE would be perfectly equal to EG. They look equal, and it turns out they are. If all else fails in these geometry problems, draw an accurate diagram and go based on what it looks. Hopefully you've learned some of these geometry theorems, but if not, going by how it looks can be very helpful. So I can subtract 3x from both sides. And that will give me 4 is 2x minus 6. Add 6 to both sides. And 10 is 2x. And x equals 5. So that gives you the answer on this one. Let's go ahead. Actually, no. Careful. X is 5, but it wants to know HF. Okay, it wants to know this thing there. Well, let's plug this in and find out something. If I plug that in, that gives me this is 3 times 5 plus 4. That's 19 for IE. And if IE is 19, then and it cuts it in half, then the whole thing there is 38. It's also true that the diagonals of a rectangle not only bisect each other like any parallelogram, but they are also equal. So if IE is 38, so is the other diagonal, so they are both 38. So that they look equal, they are equal. That's very handy for this rectangle. Let's try this one. Okay, on this one we have a triangle and it wants to know the measurement of PG, but let's look about what they gave us. In geometry problems I always say, what did they give me? They told me this value was x plus 3, and they told me PG was 4x plus 1. That's not the most helpful thing. And then it tells me this value is 2x minus 1. Now it turns out that these two values are both equal. They look equal and they are equal. The reason they are equal is those are intersecting points on that triangle. So this point here in the center of this triangle where all the angle bisectors meet, it is equidistant from all the sides. So all three of those lines there are actually equal. But I can use the fact that 2x minus 1 should be equal to x plus 3. I can solve for x by subtracting x from both sides. So x minus 1 is 3. Add 1, so I get x equals 4. Now that I know x is 4, I plug that in, and that's how I get PG. So 4 times 4 plus 1 should be 17, and that is how we get that answer. Some interesting problems here in geometry. Be sure to just kind of use what they give you and go from there. That's your best strategy. Hope this helps. We'll try some more on the next round.